In 2000, Airbus made the boldest bet in aviation history, $25 billion to build the world's largest passenger jet. Convinced that the future of travel belonged to mega-hub airports and double-decker superjumbos. Their vision spawned a plane so massive it demanded entirely new factories and even bigger expectations. The A380 briefly dazzled the world with its 2 decks, 800 seats and record-breaking luxury. But behind the glamour, a single business assumption would unravel the entire program, costing Airbus billions and shattering the dream. Why did the most audacious plane ever built mark the industry's biggest miscalculation? And what warning does its story hold for the future of flight? At the turn of the millennium, Airbus executives gathered in Toulouse to approve a project unlike anything the commercial aviation world had seen. Their answer to clogged runways and jammed terminals was simple in theory. Build a plane so large it could move more people per flight than any jet before it. Market studies from the 1990s painted a picture of relentless airport congestion, especially at global hubs like Heathrow and Singapore, where takeoff slots were scarce and passenger demand kept climbing. Airbus argued the solution was not more flights but bigger planes. On December 19, 2000, the board committed nearly $25 billion to launch the A380. The design called for a wingspan of 79.75 meters, 2 full passenger decks, and a maximum takeoff weight of 575 tons. The aircraft would carry between 500 and 850 passengers, depending on configuration. To build it, Airbus invested hundreds of millions in a new assembly line in Toulouse, as well as specialized tooling and logistics chains stretching across Europe. The company needed at least 50 launch orders to move forward and found early supporters in Emirates, Singapore Airlines, Air France and Qantas. Everything rested on the belief that the future of air travel belonged to the mega hub and that only a super jumbo could solve the capacity crunch. On October 25, 2007, Singapore Airlines made history with the first commercial flight of the Airbus A380 connecting Singapore and Sydney. The event drew headlines around the world. Tickets for the inaugural journey sold at auction, and some seats fetched more than $100,000. Passengers stepped aboard to find a cabin unlike any other, with private suites that had sliding doors, double beds, and even showers in first class. Champagne flowed, and the airline's signature service reached new heights. Reporters crowded the terminal, eager to capture the spectacle of the world's largest passenger jet lifting off for the first time. For Singapore Airlines, the A380 became a symbol of luxury and innovation, setting a new standard for long-haul travel. The double-decker layout allowed for bars, lounges, and unprecedented space, turning a routine flight into an experience. For a brief moment, the A380 was the crown jewel of commercial aviation, celebrated as the future of flight. Tim Clark, the president of Emirates, saw opportunity where others hesitated. While most airlines placed cautious orders, Clark committed his airline's future to the A380, envisioning Dubai as the world's ultimate aviation crossroads. Emirates did not just want a handful of super jumbos. It ordered 123 aircraft, nearly half of all A380s ever built. For Clark, the logic was simple: connect continents through Dubai, fill every seat with travelers from Asia, Europe, Africa and beyond, and reap the rewards of unmatched passenger capacity. The A380 became the centerpiece of Emirates' growth, enabling routes like Dubai to London, Sydney and New York to run multiple times a day, each flight carrying up to 500 people. This massive bet insulated the A380 program in its early years, providing Airbus with a steady stream of orders even as other airlines hesitated. But this reliance came with risk. With so many A380s heading to a single carrier, the program's fortunes became tied to Emirates' own strategy and the fate of Dubai's hub. For a time, Clark's vision seemed unstoppable, and the A380's future looked secure on the Arabian Peninsula. Moving parts on a scale never before attempted in commercial aviation, the Airbus A380's journey from blueprint to reality stretched across 3 countries and hundreds of suppliers. The wings, each nearly 36 meters long, were crafted in Broughton, a small town in the United Kingdom, then shipped by barge and convoy to the French border. Fuselage sections, some wider than a city bus, left Hamburg by river and road, threading through German villages before reaching the Atlantic. From Spain came the tailplane, while cockpit assemblies and nose sections converged in Toulouse, where everything would finally come together under one roof. Coordinating this supply chain required precision and trust. Each component, from the massive landing gear to the intricate hydraulic lines, had to fit perfectly with the next. Engineers in Hamburg and Broughton worked off digital plans, sending updates and revisions through a network of computers and translators. Even a small miscalculation could throw off the alignment of thousands of rivets or leave a gap in the double-decker floor. The stakes were enormous. The A380's maximum takeoff weight reached 575 tons, and every kilogram counted against range and efficiency. The sheer size of the aircraft forced Airbus to invent new ways of moving parts. Custom-built transporters, including the giant Beluga cargo plane, carried wings and sections that would not fit on any standard aircraft. On the ground, convoys rolled at walking pace through narrow roads, sometimes halting traffic for hours as they navigated hairpin turns and ancient bridges. In Toulouse, the final assembly line was a marvel in itself. A facility larger than 32 football fields, purpose-built to handle the double-decker giant. Yet as the pieces arrived, a hidden risk began to surface. Each plant relied on its own digital tools and methods, making integration a delicate balancing act. The complexity of merging so many systems and standards would soon test even the most experienced engineers, setting the stage for a challenge that would ripple through every corner of the project. Inside the assembly halls of Toulouse, the A380 project collided with a problem no amount of planning could hide. As workers prepared to thread the aircraft's nervous system, 530 kilometers of wiring, engineers discovered that harnesses arriving from Germany simply did not fit the airframes built in France. The wires, painstakingly manufactured to exacting standards, came up centimeters short or routed in ways that clashed with pipes, brackets, and bulkheads. The cause traced back to a digital rift. German teams had designed their sections using an older version of CATIA, while their French counterparts had switched to a newer release. The two versions handled measurements and bending radii differently, creating subtle but catastrophic discrepancies in the blueprints. The scale of the mismatch was staggering. Every A380 required more than 40,000 connectors and nearly 100,000 individual wires, all routed through tight spaces across 2 decks. When the first prototype reached the wiring stage in 2004, it became clear that nothing matched as intended. Harnesses could not simply be stretched or patched. Each needed to be stripped out, redesigned, and rebuilt from scratch. Because electrical resistance and safety standards ruled out quick fixes, the only solution was to start over. To tackle the crisis, Airbus relocated over 1,100 engineers from Germany to Toulouse. For months, teams worked around the clock, rethreading miles of cable through the double-decker fuselage. The assembly line ground to a halt as rework cascaded into every corner of the project. Customization requests from airlines and late-stage design changes only deepened the backlog. What began as a software oversight turned into an 18-month production delay, pushing back deliveries and straining relationships with launch customers. The wiring catastrophe exposed the fragility of Airbus's cross-border integration and forced the company to confront the limits of its own ambition. News of the wiring crisis rocked Airbus's parent company EADS and sent shockwaves through the financial markets. An 18-month delay triggered a cascade of penalty payments to frustrated airlines, with total costs from compensation and lost revenue climbing to $6 billion. Financial executives scrambled to reassure investors, but the numbers left little room for comfort. On June 13, 2006, when the first major delay was announced, EADS shares plunged 26% in a single day, wiping out billions in market value almost overnight. The blow landed hardest in Paris and Frankfurt, where institutional investors and pension funds held large stakes in the company. Inside Airbus headquarters, the mood shifted from pride to panic. Finance teams pored over contracts lined with penalty clauses, each one activated by missed delivery milestones. Key customers like Emirates and Singapore Airlines demanded compensation while future orders hung in the balance. Cash flow projections, once buoyed by visions of superjumbo profits, now showed widening gaps. Executives faced hard questions from board members and government stakeholders who had backed the project with subsidies and political capital. The stock market reaction was swift and unforgiving. In trading rooms across Europe, analysts slashed their ratings on EADS and questioned the company's ability to manage risk on such a massive scale. Headlines in the Financial Times and Le Monde chronicled the fallout, quoting investors who saw the A380 as a cautionary tale of unchecked ambition. For months, the share price struggled to recover, and the company's reputation for engineering excellence came under fire. The financial shock did not just hurt the balance sheet, it eroded confidence in Airbus's leadership and exposed vulnerabilities in its multinational structure. As the penalty payments mounted, the dream of the A380 as a profit engine faded, replaced by urgent conversations about damage control and survival. The project's fate was no longer just an engineering challenge, it had become a test of financial resilience and corporate credibility. While Airbus wrestled with production setbacks and soaring costs, the commercial aviation landscape was quietly tilting in a new direction. Airlines were no longer convinced that the future belonged to giant four-engine jets flying between mega hubs. Instead, attention shifted to a new breed of aircraft. Twin-engine wide-bodies promising unprecedented efficiency and flexibility. Boeing's 787 Dreamliner entered service in 2011, equipped with advanced composite materials and engines that burned roughly 20% less fuel than earlier models. With a range of 7,635 nautical miles, the 787 could connect cities that had never before seen direct service, bypassing congested hubs entirely. Airlines flocked to the Dreamliner not just for its fuel savings, but for its ability to operate profitably with far fewer passengers. The 787's break-even load factor hovered around 65%, a far cry from the 80% needed to make the A380 viable. Airbus, recognizing the momentum, launched its own answer, the A350 KWB. This twin-engine jet matched the 787's efficiency and offered seating for 300 to 400 passengers, with a range that rivaled or exceeded the A380. The A350's composite construction and new generation engines delivered lower operating costs, and its smaller size allowed airlines to adjust capacity without the risk of flying half-empty superjumbos. For strategists at both Boeing and Airbus, the numbers told a clear story. Airlines wanted jets that could serve a wider variety of routes, adapt to swings in demand, and minimize fuel and maintenance costs. The age of the superjumbo was giving way to the era of the efficient twin, where flexibility and economics mattered more than sheer size. By 2015, the promise of the A380 had faded into a hard accounting problem for airline executives. The order book, once a symbol of industry optimism, had stalled at 318 firm commitments. Only 251 aircraft would ever leave the assembly line. The math was relentless. Airbus needed to sell at least 1,000 to 200 to break even. Instead, the backlog thinned, and one by one, airlines began to reconsider their place in the program. Qantas, once a vocal supporter, found the economics impossible to justify. Their A380s struggled to fill enough seats on long-haul routes to London and Los Angeles. Operating costs soared, and the airline quietly trimmed its order, then retired jets early, some after barely a decade in service. The superjumbos' 4 engines demanded constant maintenance, and each flight required near maximum occupancy just to cover expenses. For Qantas's finance team, the numbers no longer worked. Air France faced a similar dilemma. After taking delivery of its initial batch, the airline declined to order any more. Their A380s flew select routes, but often at a loss, weighed down by high fuel bills and inflexible scheduling. As competitors switched to more nimble twin-engine jets, Air France's superjumbos became a liability. The carrier began withdrawing them from service well before the end of their expected lifespan. Across the industry, the story repeated. Airlines trimmed fleets, deferred deliveries, or exited the A380 program entirely. The backlog shrank to a trickle. With new orders drying up and existing customers looking for exits, the economic pain was no longer confined to Airbus. It spread to every operator who had once believed in the superjumbo dream. In February 2019, the final verdict arrived. Emirates, the A380's most loyal customer, cut its order by 39 aircraft, reducing its commitment from 162 to 123. With the backlog evaporating, Airbus faced a reality it could no longer postpone. On February 14, 2019, Airbus CEO Tom Enders said, "We have no substantial A380 backlog and hence no basis to sustain production." The announcement ended nearly 2 decades of ambition and struggle. For airlines, the decision was both a relief and a reckoning. Lufthansa, Air France, and others moved quickly to retire their superjumbos, sending them to storage yards in the Mojave Desert and Teruel, Spain. Some jets were less than 10 years old when they joined rows of mothballed giants, their engines wrapped and their windows taped against the dust. The COVID-19 pandemic in 2020 delivered the final blow. As long-haul demand collapsed, A380s became liabilities overnight. Airlines grounded their fleets, and many declared they would never return to service. The economics simply did not add up. 4 engines, high maintenance, and the need to fill hundreds of seats on every flight. By December 2021, the last A380 rolled out of Toulouse, bound for Emirates, in a quiet ceremony that closed the chapter on the world's largest passenger jet. In the end, only 251 aircraft were built, far short of the 1,200 needed to break even. The losses amounted to more than $10 billion, a hard lesson carved into the balance sheets of Airbus and its partners. Today, the A380's legacy sits in the desert sun, a monument to ambition and risk, and the unforgiving realities of the aviation business. Today, airlines order twin-engine jets by the thousands, while 251 A380s gather dust in desert storage. In aviation, efficiency, not ambition, writes the future. The A380's fate is a warning. Even the boldest engineering must answer to economic reality. As travel patterns keep shifting, the next $25 billion bet will demand sharper vision and far greater humility. What risk do you think the industry will take next?